61. That's how many workers, out of every 100,000, died running American machines in 1913 alone, not in a war, just at work. This is a list of 100 of those machines, the ones doing that, killing between 1900 and 1950. Industry mechanized that half-century top to bottom. Structural iron, irrigated farmland, strip-mined coal seams, riverbeds dredged wide enough for ships, using machines bigger, faster, and hungrier than anything before them. Not a highlight reel of the worst disasters on record, a catalog, because on every single one of these 100, the danger wasn't the exception. It was the baseline the machine ran on. None of the men who ran these machines ever clocked in expecting a clean shift. Heat, height, blade, pressure, dust. That was Tuesday. And we're not ranking these 100 by who killed the most. Every one of them killed plenty. We're starting with the machines you'd recognize on sight, ending with the ones doing the same killing in total obscurity. Some of the men standing next to these machines, in the photographs you're picturing now, had less than a year left to live. They had no idea. Neither did the man standing beside them. And there's one part missing from almost every machine on this list. One part, cheap to make, simple to bolt on, and it would have saved thousands of these men. Nobody installed it, and by the end you'll understand exactly why. Start with the Bucyrus. 95 tons of steam shovel. A 5 cubic yard bucket repping 8 tons of rock from a mountainside in one bite, and a 4-man crew riding a boiler that did the work of 100 men with picks. 2 firemen kept the boiler fed, an engineer ran the controls, a craneman worked the dipper, and 6 more men laid the rails it crawled on. That machine helped carve Panama's Culebra Cut. Hell's Gorge, the men called it. Chewing through dynamite-shattered rock so fast, it sometimes ate through unexploded charges nobody had found yet. A December 1908 blast like that killed 23 men in a single afternoon. The official canal death toll stands at 5,609. Most historians think it was higher. Marion built the Bucyrus's twin rival, and together, the two companies supplied most of the 95-ton fleet that dug the canal. One shovel alone once moved 70,000 cubic yards of rock in 26 days, a record at the time. The same boiler that powered the dipper's swing powered the crew's daily gamble. Pressure in the hundreds of pounds per square inch, on rails laid through jungle, actively trying to swallow the machine whole. Landslides at Culebra eventually buried 75 acres of the town itself. A Marion shovel didn't need a rival to kill a man. The ground underneath it did that for free. The steam locomotive didn't just haul the machines on this list to their job sites, it killed the men who built and ran it, on a scale none of them matched. Brakemen had it worst. Before automatic couplers and air brakes became standard, they ran across moving car roofs and dropped between cars by hand to set brakes. One of the deadliest jobs in American industry. 75,000 American railroad workers died laying and maintaining track in the quarter century before 1920, roughly 3,000 a year, crushed between couplers, thrown from moving cars, or scalded by a boiler that let go without warning. Then there's the riveting gang. 4 men, 1 pneumatic hammer and a forge. For 30 years, the only way to assemble a skyscraper's steel skeleton. They worked hundreds of feet up on bare beams, with no safety nets and no harnesses. Balance and nerve the only thing between them and the street. The heater fired a rivet, white hot, and threw it. The catcher snatched it from the air in a metal cone. The bucker-up held it against the beam, and the riveter hammered it flush with a tool that could pop a man's eardrums by lunchtime. Missed the catch, and the rivet fell on whoever stood under the scaffold, a recognized cause of death. Next is the pile driver. Its job was dropping a multi-ton weight from height onto a wooden or steel pile, over and over, sometimes hundreds of times on a single bridge or pier, until the ground gave up. The same mechanism that could punch a bridge foundation 40 feet into a riverbed could just as easily kill a man if the hammer slipped its guide, or if a worker leaned in to clear a jam between drops. After that comes the wrecking ball, converting a crane's swing into pure kinetic violence against a wall no longer supposed to be standing. A job that used to mean a demolition crew with sledgehammers and crowbars, building by building for weeks. The same momentum that could drop a 5-story facade in one pass turned any miscalculated swing, a cable run too long, a building falling the wrong direction, into a wall of masonry that buried or killed the ground crew below. A steam dredge did its share too, chewing through a riverbed at a rate that turned shipping channels and harbors into reality decades ahead of schedule. Dredges like it deepened stretches of the Houston Ship Channel in the lower Mississippi, turning landlocked towns into deep-water ports almost overnight. It sucked up mud and silt through a cutterhead spinning fast enough to slice through buried debris without slowing down. And it would slice through a snagged cable, a sunken hull, or a diver sent to clear the suction pipe with the same indifference. Right alongside it worked the steam crane, capable of swinging loads of 50 tons or more, lifts that used to take a pulley gang an entire day, with the boiler power to swing locomotives and finished girders across a job site. That same pressure was behind the crane fires and boiler explosions that fill the era's accident logs, and a snapped hoist cable under load wouldn't drop its burden gently. It whipped back through the operator's cab first, hard enough to kill him before the load hit the ground. 8 machines in, and we haven't even left the names you already recognize. Keep that lethal baseline running underneath everything that follows, because it never actually turns on. Up next is the threshing machine. A steam belt rig and its crew of a dozen men could thresh a farm's entire wheat crop in a single day, work that used to take a week of hand-flailing, spinning an exposed cylinder of teeth indifferent to whatever got fed in alongside the wheat. Loose sleeves, a hand clearing a jam, a boy keeping the feed steady. Threshing accidents were common enough that farm almanacs ran annual warnings about them. Then there's the cotton gin. A mechanized gin could clean as much cotton in a day as 50 hand workers picking seeds out by hand. Its saw-toothed cylinder pulling fiber through narrow slots faster than any hand could manage. That exact same slot-and-tooth mechanism took fingers and occasionally whole hands from workers feeding it, especially since it usually ran with no guard over the intake at all. Textile mills leaned just as hard on the power loom. By the 1900s, a single weaver might tend a dozen looms at once, walking a row of frames all snapping at full speed, the flying shuttle weaving cloth at a rate hand looms couldn't approach. That speed occasionally sent the shuttle flying out entirely, a wooden projectile aimed at whoever stood nearby, while the belts and gears beneath the frame scalped any worker, often a child, whose hair got too close while cleaning it running. Steel had its own monster in the Bessemer converter, capable of turning several tons of pig iron into usable steel in about the time it took to read a newspaper. Blasting air straight through the molten metal did that work, turning a multi-day refining process into 20 minutes. And the same violent oxygen blast could also turn into a geyser of white-hot metal and sparks, Bessemer snow, if the charge boiled over, burning the floor crew wherever the droplets landed. Underground, the rock drill did its own kind of killing. A 2-man crew with a pneumatic drill could bore in a single day what a hand driller took a week to manage, and the same fine rock dust it threw into the air with every strike killed thousands of miners slowly through silicosis long after the shift ended. The Hawk's Nest Tunnel in West Virginia drilled dry instead of wet to save time. At least 764 of roughly 3,000 underground workers were dead from it within 5 years. Above ground, farmers had the dynamite plow. By the 1910s, farm supply catalogs sold dynamite by the case specifically for stump and rock clearing, marketed as a labor-saving convenience. Charges blasted tree stumps and buried rock out of fields no plow could touch, turning weeks of grubbing labor into an afternoon. The same charge that shattered a stump in seconds could detonate early in bad weather or in a hand that misjudged a fuse, and agricultural extension offices spent decades publishing warnings farmers largely ignored. In the woods, it was the steam donkey. A single donkey and its mile of cable could clear a hillside in weeks that would have taken horse teams an entire season. The winch dragged felled timber out of terrain no team of horses could manage, hauling logs the length of a football field in seconds. And that same cable, under tons of tension, occasionally snapped. Loggers called the recoiling line a widow maker because it could cut a man in half before anyone heard the bang. Then came the circular sawmill. A good rake could turn out tens of thousands of board feet in a single shift, lumber that once took a sawpit crew weeks to produce by hand. A blade spinning at full speed could turn a 100-year-old log into lumber in minutes. And that same speed meant a knot, a buried nail, or a kickback could send a piece of wood or a fragment of the blade itself flying back at the operator hard enough to kill. 16 down. Notice none of these machines needed a freak accident to kill somebody. The killing was built into the spec sheet. But up in winter territory, railroads turned to the rotary snowplow, which could open a mountain pass in hours where hand crews with shovels had once taken days. It chewed through drifts that have stranded a train for days, spinning a wheel of blades fast enough to fling snow, and anything buried in it, clear of the tracks. Crews clearing ice jams ahead of the blades did it, with the engine idling close enough to start again before anyone was clear. Down in the mines, the coal-cutting machine raised the stakes. A mechanical cutter could undercut a coal face in an hour that a pick miner needed a full shift to manage, pulling seams apart using a chain or disc blade that could spark against pyrite and ignite the methane the digging released. A documented contributor to the wave of mine explosions that by 1940 finally forced federal mine inspection. Above those mines sat the blast furnace, pouring out hundreds of tons of iron a day, around the clock, sometimes running for years without ever shutting down. Every one of those tons of molten iron and slag was a burn injury waiting for a single misstep on the casting floor. A slip, a clogged tap hole blowing open, a pocket of furnace gas that could silently overcome a man on the platform above. On the construction side, the derrick did its lifting. A single boom and cable could raise loads that would have taken a block and tackle gang of 20 men or more, swinging finished steel and stone hundreds of feet into place. The guy wires holding that boom steady could fail under load, and when they did, the boom didn't fall slowly. Men killed by swinging derrick, ghouls, show up often enough in the era's records to count as their own category of death. By the 1930s, RG's Lichwanos giant cable-operated scrapers and bulldozers could move in a single pass what a horse-drawn grading crew needed days to shift. More earth per man than any machine before them, dragging blades through soil, using steel cable under enormous tension. A cable that snapped mid-pull didn't go limp. It whipped back across the cab and ground crow with the force of everything that had been straining against it a moment earlier. Caterpillar's crawler tractor worked the same ground differently. Its continuous tracks let it cross mud and grades that would have buried a wheeled tractor to the axles climbing terrain wheels couldn't touch. And that low-slung, heavy chassis made it nearly impossible for an operator to see a man near the machine's blind spots. A problem that shows up again and again in the era's accident reports. Back at the coalfields, a coal breaker's job was simple. Crush anthracite and sort it by size on conveyor belts fast enough to keep up with the mine's output. A single building could process 1,000 tons of coal a day, sorted entirely by boys' bare hands, moving faster than they could think. Boys as young as 8 or 9 did the sorting, perched over those belts for hours and paid for it in fingers, hands, and sometimes their lives, when loose clothing or an exhausted reach caught in the gears. To dig the Brooklyn Bridge's underwater foundations, workers descended into pressurized iron boxes called caissons, sunk into the riverbed, and pumped full of compressed air to hold back the water. The Manhattan Tower's caisson reached nearly 80 feet down before Roebling finally called a halt. That same air dissolved gas into their bloodstream, and rising too fast turned that gas to bubbles in their joints and blood. Caisson disease. The bends. Roughly 20 died from it. Washington Roebling himself was left partially paralyzed for life. Those 24 are the machines you'd recognize from a photograph. Everything from here did the exact same killing, with none of the fame. Alvin Lombard's steam log hauler dragged sled trains of timber down iced logging roads at a pace horses could never match, using crawler tracks to pull loads that would have snapped any team's harness. On a downhill ice road, momentum became the danger. An overloaded sled train could outrun its own brakes and crush the crew riding it. Right behind it came the high-wheel skidder, sometimes called cattle-a-whales. Giant wooden wheels used to drag whole logs clear of the cutting site, without a wagon bed to hold them. The chains lifting a log's front end off the ground could shift or snap on uneven terrain, swinging tons of timber sideways into whoever was walking alongside. On the Great Lakes ore docks, it was the Hewlett unloader. A single rig could empty a freighter's hold of 10,000 tons of iron ore in hours, a job that used to take a gang of shovelers days. It sent its operator down into a ship's hold, riding the machine's own clamshell bucket, scooping ore at that pace with no clear sightline for the deckhands below, and a miscued drop of that bucket could crush a man against the hull. Dam and canal sites ran on the cableway system, steel cables strung across canyon and dam sites to deliver concrete buckets exactly where crews needed them, replacing weeks of hauling with a controlled drop from overhead. A cable under that load needed only one flaw: a frayed strand, an overloaded bucket, to drop tons of wet concrete onto the crew waiting below. Back underground, the mechanical coal loader sped up the whole operation, letting a crew load a shift's output in a fraction of the time hand shoveling took, inside a roof that hadn't been reinforced for the new pace. Speeding up the loading didn't speed up the roof bolting, and an unsupported section above a fast-moving loader was a documented cause of fatal roof falls. Textile country had the spinning mule, drawing and twisting cotton thread across a moving carriage faster than any hand spinner, and small children called scavengers were sent underneath it, while it ran, to clean lint from the moving parts. Long-term exposure to the mineral oil on the mule's spindles was later linked to a documented cancer among mule spinners, a slow danger riding on top of the obvious one. Right beside it sat the carding machine, combing raw fiber into aligned strands using cylinders studded with thousands of fine wire teeth, processing in minutes what hand carding took all day. Loose hair or clothing caught in those teeth didn't just tear free. Scalping injuries from carding machines show up often enough in mill records to be a recognized textile hazard. In the print trade, it was the Webb rotary press, printing, cutting, and folding newspapers by the tens of thousands per hour, feeding a continuous roll of paper through rollers running far faster than a hand could react. A jam meant reaching toward those rollers while the press kept running, and pressmen losing fingers to the in-running nip point was a known trade hazard. Metal shops depended on the power stamping press just as relentlessly, punching out finished parts in a fraction of a second, repeating the same motion thousands of times a shift. With no two-hand safety interlock built in yet, a hand reaching into the die a half-second too early simply became part of the stroke, and lost fingers or the whole hand to it. Foundries had the ladle crane. It carried molten metal weighing tons across the floor, suspended from cable and hooked directly over the men working below. A ladle that tipped, jammed, or dropped didn't spill. It erupted, and foundry burn injuries from spilled molten metal were frequent enough that some shops kept dedicated burn wards. Shipyards ran their own crusher in the plate roller. It bent steel hull plate to a ship's exact curve, feeding it between massive rotating cylinders under enormous pressure. Those rollers had no patience for a hand or sleeve caught at the feed point, and shipyard records list crushed limbs from plate rollers as a recurring entry. Chicago's packing houses ran disassembly on an overhead trolley system, moving carcasses past a line of workers, each doing one repeated cut, fast enough to process thousands of animals a day. A single plant could turn out more dressed meat in a shift than an old-style butcher shop saw in a year. Wet floors, swinging hooks at head height, and knives moving at speed made the line itself the hazard. Accident rates in early-century packing houses were among the highest of any American industry. Out on the farm, it was the mechanical corn picker. Its snapping rolls pulled stalks through to strip the ears at a note no hand picker could match. Those same rolls pulled in arms and hands with equal indifference if a farmer reached in to clear a jam. Common enough that corn picker arm became its own entry in farm accident records for decades. The early combine harvester worked the same fields a different way. It cut, threshed, and cleaned grain in one pass, eliminating an entire separate threshing step. Its belts, augers, and exposed tri-shafts ran the whole time the machine moved, and a sleeve or pack leg caught anywhere along that drivetrain pulled the rest of the man in behind it. Back on the skyscraper frame, the rivet heater's forge had its own danger. The portable coal forge that heated rivets to thawing temperature sat on bare planking hundreds of feet up, fed by hand all day. A dropped rivet or a forge tipped by a gust didn't just burn the heater. Red-hot metal falling through open scaffolding put every man below at risk too. Farms had their own boiler wrist in the traction engine. It had enough power to pull plows, threshers, and wagons across ground no team of horses could manage alone. That same boiler, poorly maintained or pushed past its rated pressure, was a documented cause of steam explosions violent enough to kill the engineer at the controls. Out on the rails, mechanical track layers sped up an entire industry. They could set rail sections in place at a pace that turned railroad expansion into a project measured in months rather than years. Each section weighed hundreds of pounds, and a hand or foot caught between a settling rail and the machine's placement arm rarely came away intact. California's hydraulic grinding monitors blasted water at pressures high enough to strip entire hillsides to bedrock in days, washing gold-bearing gravel loose faster than any pick crew. That jut could kill a man outright at close range. And the hillsides it undermined collapsed without warning onto the crews below. Elsewhere on the dig site, cable excavators multiplied the output. Steam-driven winches dragging a bucket through earth too dense for a simple scoop. Every one of those winch cables operated under the same tension that made wire rope failures, when they happened, violent enough to kill anyone in the cable's path. Strip mines eventually scaled that up into the walking dragline, using massive feet to shuffle itself across soft ground a wheeled machine would sink into, swinging a bucket on cable across distances no shovel could reach. A snapped drag cable under that load released stored energy that had nowhere to go but through whoever stood nearby. Underwater, tunneling shields carried a stranger danger, pushing through soft riverbed mud using compressed air to hold back the water pressure that would otherwise flood the bore. When that air escaped through a weak spot in the mud above, it took the path of least resistance. And on at least one documented Hudson River job, that path ran straight through the riverbed, shooting a worker up through the silt into the river above. A blowout that could kill outright if he wasn't pulled clear fast. Steam-making's other furnace, the open hearth, traded speed for scale, refining far more steel per batch than the Bessemer process by holding molten metal in open view for hours instead of minutes. That extended exposure meant more time for a clogged tap hole to blow, more time near furnace gas that could quietly overcome a man before anyone noticed. Right past the furnace stood the rolling mill, its paired cylinders flattening red-hot steel into sheet and rail in a single continuous pass. Those rollers offered no resistance to a sleeve or glove caught at the bite point, and "rolled in" was common enough mill shorthand to need no further explanation. Forges relied on the drop hammer for the heavy work, shaping red-hot steel with repeated multi-ton blows, doing in seconds what hand forging took hours to accomplish. The same falling weight that shaped a part could crush a hand reaching to reposition the workpiece between strikes. And a hammer that released early, before the operator's signal, was a documented and feared malfunction. 48 machines in. Remember the men from the start. Some of them already had less than a year left and they still didn't know it. Every machine since then has been running on that same arithmetic. Smaller foundries leaned on the cupola furnace instead, melting scrap iron continuously for an entire shift and tapping off molten metal at intervals through a hole at its base. Tapping that hole wrong, or too soon, sent a stream of liquid iron toward whoever stood closest, common enough to be a routine entry in foundry first aid logs. Getting crews underground at all meant trusting the cage hoist, lowering and raising entire mining crews down a shaft at speed, sometimes dropping them 1,000 feet in under a minute, on a cable that was, for the length of the ride, the only thing between them and a fatal drop. Hoist cable failures were rare individually, but across thousands of mines running thousands of shifts, they added up to one of the most feared categories of mining death. Once the ore came up, the stamp mill crushed it. Heavy iron stamps dramping onto rock in continuous rhythm, pulverizing in minutes what would have taken a crew days by hand. That crushing action, and the fine silica dust thrown into the air, made stamp mills a documented source of both crush injuries and the same lung disease that killed rock dwellers. Quarries ran a different version, the rock crusher, reducing quarried stone to gravel at an industrial rate, jaws or rollers closing with enough force to break granite. Clearing a jam meant reaching into a machine built specifically to crush stone, and that math rarely favored the worker. On the roads themselves, the steamroller did the flattening, its weight the entire point, multiple tons compacting new surface in passes no hand tamper could match. That same weight, on a machine with limited visibility and slow stopping distance, made it a documented cause of crew members being run over and killed on active job sites. Up on the skyscraper frame, the material hoist did the lifting. A rope and pulley rig carrying brick, steel, and concrete to the top far faster than men could carry it upstairs. A frayed rope or overloaded platform let go without warning, and falling load deaths from material hoists were common enough in the 1920s building boom that contractors simply budgeted for them. Rail yards used the locomotive crane for the heaviest lifts, combining a rail-mounted chassis with a full crane boom to move loads directly to wherever the line reached. Its high center of gravity made it prone to tipping past rated capacity, and a tipped crane came down boom first, crushing whoever was standing below it. Back in the quarry, the channeling machine cut the blocks free, a reciprocating chisel bar cutting deep grooves into stone that would have taken a crew days to free by hand. The bar's repeated strikes ran inches from the operator's hands all shift, and a slip at the wrong moment cost fingers with mechanical regularity. A different blade hazard sat just past it, the gang saw. Multiple parallel blades cutting through a stone block at once to multiply a single saw's output. Quarry workers feeding and adjusting blocks worked within inches of all those blades simultaneously, and a single miscalculated reach could cost a hand to more than one blade at once. Utility crews used the mechanical trencher to dig fast, cutting a ditch in an afternoon that would have taken a hand crew a week. Speed meant trench walls went up faster than they could be properly shored, and trench collapse, burying a worker at the bottom, remained one of the most common ways trenching work killed a man. Demolition crews carried the pneumatic breaker, shattering old concrete and pavement at a rate that made hand sledgehammers obsolete almost overnight. The same vibration that did the breaking transmitted straight up through the operator's hands and arms every shift, and the silica dust thrown up by every strike settled into the same lungs rock drilling damaged. Back in cotton country, the hydraulic bale press did the compressing, packing a season's loose cotton into dense, shippable bales using force measured in tons. Anyone caught between the press head and the bale chamber when the cycle started had no margin. The press didn't recognize the difference between cotton and a limb. Up north, farms used the steam-powered hay baler the same way, compressing and tying loose hay into bales fast enough to keep pace with an entire harvest crew. Dust from dry hay packed at that speed made baler fires a recurring hazard, and the same compression chamber that baled hay closed on a hand just as efficiently. Loggers also used big wheels, tall, oversized wooden-wheeled carts that dragged entire tree trunks clear of the cutting site with the load's front end lifted off the ground. An uneven pull or a panicked team could swing that suspended log sideways into the men walking alongside without warning. In the refinery, the sugar centrifuge handled the final separation, spinning raw sugar at speeds that separated crystal from syrup in minutes instead of the days settling once took. A drum that failed at that speed didn't slow down gracefully. It came apart, violent enough to be treated as its own category of plant disaster. Brickyards ran the power press just as hard, stamping finished bricks from wet clay faster than any hand mold, repeating a single crushing stroke thousands of times a day. That stroke showed no more mercy to a hand reaching into the die than it did to the clay. Tanneries had their own blade in the splitting machine, a long horizontal blade slicing hides to a uniform thickness in one pass, what a hand knife took an hour to do. Feeding hides close to a blade that fast cost tannery workers fingers often enough to knock at one of the trade's most dangerous stations. Grain elevators ran on the conveyor leg, moving tons of harvested grain into storage silos in minutes on a continuous belt running the full height of the structure. The fine grain dust that leg kicked into the air was explosive in concentration, and grain elevator explosions tied to that dust remain among agriculture's most catastrophic recurring disasters. Paper mills had a similar danger in the beater, rotating bladed cylinders, pulping rags or wood fiber into usable stock continuously through a vat. Reaching in to clear a snag put a hand directly into the same blades doing the pulping, a well-documented source of severe hand injuries. Not every machine here only took. The Owens bottle machine gave something back. Michael Owens's automatic design could blow finished glass bottles by the dozen with no human hand near the molten glass, eliminating a job that once required boys to carry hot glass by hand all day. It's one of the rare machines on this list whose purpose was removing a danger, and it worked, cutting child labor in glass houses within a decade. Slate Country ran its own saw on the quarry edge, a thin, abrasive blade cutting roofing slate to thickness far faster than a hand chisel, working stone pulled from steep, open pits. The same fine slate dust the saw produced caused lung disease in quarry workers, on top of the ordinary risk of working a blade at the edge of a pit with no guardrail. Down at the docks, the steam winch closed out this stretch of the list, loading and unloading cargo holds at a pace hand hoisting never matched, running cable through blocks and pulleys under heavy, repeated strain. A snapped cable under that load whipped back across the deck hard enough to take off a limb or a head, and stevedoring stayed one of the deadliest trades in any port city for decades. 70 machines down. From here the names get smaller and the machines get stranger, but the danger never once let up. Winter had its own machine in the ice plow. Horse-drawn plows and circular saws let crews harvest blocks off frozen lakes by the ton for the era's ice trade. Thin ice, drowning, and saw blade lacerations made ice harvesting one of winter's most dangerous seasonal jobs. Down south, cane country had the cane mill rollers. They crushed stalks to extract juice continuously through the harvest season. Those same rollers famously pulled in hands and arms, which is why some of the earliest machine safety levers in American industry, quick reverse mechanisms, first appeared on sugar mills, not factories. Rice country depended on the power hauler. It could strip rice husks at volumes hand-pounding never approached. The husk dust the machine threw off in clouds was a documented fire and explosion hazard in rice mills running at full capacity. Oil mills crushed cottonseed and linseed the same brutal way. Hydraulic presses did it at a scale hand presses couldn't touch. Oil-soaked fiber waste piling up near the press was prone to spontaneous combustion, and oil mill fires were a recurring hazard of the trade. In shoe factories, it was the lasting machine. Fast reciprocating jaws shaped leather over a shoe form, doing work that once took a cobbler's hands all day. Massachusetts shoe factories logged hand injuries from lasting machines, often enough to make the job a recognized risk category. Wire mills relied on the wire drawing machine. Steel rod was pulled through a series of dies to thin it into cable wire, winding it at speed onto rotating drums. Wire under that kind of tension that snapped didn't drop. It lashed across the room. Nail factories ran the cut nail press. It stamped finished nails from sheet steel at a rate that made hand-forged nails obsolete almost overnight. It was also, unceremoniously, one of the most common sources of finger amputation in the entire metalworking trade. Plywood manufacturing depended on the veneer lathe. It spun an entire log against a fixed blade, peeling continuous sheets of thin wood. A misfeed sent splinters and flying veneer toward the operator at the same speed the log was spinning. Cooperages used the stave saw. It cut barrel staves to shape fast enough to keep a cooperage supplied for an entire bottling or shipping operation, and like any unguarded blade running that fast, it took fingers from anyone who fed it wrong. The sawdust it produced in volume also turned cooperage shops into one of the era's more reliable sources of shop fires. Cloth finishers used the napping machine. Wire-toothed rollers dragged across woven cloth at speed to raise a soft finish. The same teeth that raised the nap caught hair and clothing with the same enthusiasm carding machines did. Wool mills ran the carbonizing machine before carding even started. Raw wool was bathed in dilute sulfuric acid to burn away plant matter. Acid splashes and fumes made carbonizing one of the textile mills more corrosive and least discussed hazards. Hat factories turned to the fouling machine. Heat, pressure, and a mercury solution matted fur fibers into solid felt. Hatters who worked the fulling room for years absorbed enough mercury vapor to develop tremors and confusion, which is exactly where the phrase "mad as a hatter" comes from. Cheaper paper grades depended on the rag-cutting machine. It shredded used cloth into pulp stock, processing material gathered from anywhere rags could be sourced. Workers sorting and feeding contaminated rags occasionally contracted anthrax from the material itself, a disease that earned its own grim nickname, rag sorter's disease. Tinning works ran the Panama mine. Steel sheet passed through baths of molten tin and lead alloy, line after line, all shift. Metal fume exposure and the constant risk of a splash from the bath made tinning one of the trade's quieter, slower-killing jobs. Button factories ran their own lathe. Shell and bone were turned into finished buttons at a pace hand-carving couldn't match. The fine shell dust thrown off by the cutting wheel settled into workers' lungs the same way stone dust did in a quarry. Stone yards depended on the polishing lap. Marble and stone surfaces were ground and buffed to a finish hand polishing took days to achieve. Constant silica dust and wet, slick floors made the polishing room one of the quarry trade's more routinely overlooked hazards. Packing material came from the Excelsior shredder. Blades cut softwood into the fine curled wood wool used for packing, fast enough to process logs into shavings in seconds. Those same dry shavings in volume made Excelsior mills catastrophically prone to fire, on top of the obvious bleed risk to whoever fed the logs in. Bottlers depended on the cork cutting machine. A fast blade sliced raw cork into bottle stoppers and gaskets at industrial volume. The blade took fingers from careless feeding just as readily as it took cork, and the fine cork dust it produced with every cut filled the cutting room's air and the workers' lungs by the end of a shift. The tannery's rotating drum handled curing a different way, soaking hides for hours in chrome and lime solutions to cure leather at a pace pit tanning by hand never matched. Workers handling hides straight out of those drums developed documented chemical burns and ulcers on exposed skin, a recognized tannery trade hazard. Rope makers worked the rope walk spinning wheel. Fiber was twisted into cordage along buildings sometimes a quarter-mile long, with workers walking backward, feeding strands the entire length. A loose strand catching a sleeve at speed pulled a worker toward the spinning wheel before he could plant his feet. The brickyard's pug mill handled the clay mixing, rotating blades churning clay and water into a workable consistency for brick making continuously through every batch. Clearing a jammed vill meant reaching into a machine built to pulverize stiff clay with predictable results for fingers. Tobacco country had the stemming machine. It stripped the woody center rib from tobacco leaves at a volume hand-stemming crews couldn't approach. Fast-moving rollers feeding leaf after leaf made the machine a steady source of crushed and amputated fingers. Match factories kept a dipping line of their own. Racks of wood splints were coated in flammable compound at high volume. Earlier in the trade's history, white phosphorus formulas exposed dippers to a documented bone-destroying disease nicknamed phossy jaw before safer formulas phased it out. Broom factories ran a winding machine of their own. A rotating wire winding head bound bundles of broom corn fiber onto handles, doing in seconds what a hand broom maker took minutes to finish. The same head that wrapped wire around a handle roped fast as readily around an unwary finger. Basket makers used the willow stripping machine. Soaked willow rods were fed through fast rollers to strip the bark for weaving. A rod that kinked mid-feed pulled a worker's hand toward the rollers along with it. Print shops also relied on the linotype. An entire line of type could be set from molten lead in seconds, replacing what had been hours of hand-setting individual letters. Printers working the machine for years absorbed lead fumes from the casting pot, a slow, well-documented occupational hazard of the print trade. Insulation mills carded and spun a more insidious material, raw asbestos fiber, processed into yarn and cloth on the same kind of machines that handled cotton and wool. They threw fine asbestos fiber into the mill air with every pass, and workers who spent years in those mills developed asbestosis decades before the danger was widely understood or acted on. Back on the farm, the power fanning mill cleaned the harvest. A fan blasted grain to separate chaff from kernel at volumes hand winnowing never reached. Exposed belts and a spinning fan blade running at full speed made the mill a routine source of farm equipment injuries. Commercial laundries ran the steam mangle. Wet linens were fed between heated rollers to press and dry them in one continuous pass, far faster than any hand iron. Reaching to free a snagged sheet pulled a hand into the same rollers doing the pressing, a well-known hazard of industrial laundry work. And the list ends, fittingly, with the powered grist mill. An auger and grinding stones ran continuously through every batch, turning grain into feed and flour at a volume no handquarn could match. It's an ordinary machine to close on, because that was the whole pattern. Nothing on this list needed to be exotic to be lethal. It just needed to run. 100 machines, and every one ran on the same logic. Take a task that used to need careful, slow, human hands and replace it with speed, weight, or pressure that didn't know the difference between material and flesh. That was the design philosophy of the first half of the 20th century. Build it fast, build it strong, worry about the guard later, if at all. And that's the part missing from nearly every machine on this list. Not a missing genius or material, but a guard, a sheet of metal bolted over a gear, a blade, a nip point, cheap, simple, and left off because it slowed the machine down by a fraction, and a fraction of a percent of output mattered more than a fraction of the workforce. It took until 1970, after Hawk's Nest, after the Breaker Boys, after 100 machines doing this same math in 100 industries, for the law to finally require it. These machines didn't go extinct because someone cared. They went extinct because diesel, electricity, and automation made them obsolete first. The caring came later, once the bodies added up to a number nobody could keep ignoring. 100 machines, no guards, all bone and steam and nerve. That's the bill, and somebody already paid it.